Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UNIVAC, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the themes, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UNIVAC.
The essence of my existence is abstract mathematics that is impenetrable to most research scientists, and solving grand challenge initial boundary value mathematical problems and solving them by massively parallel supercomputing their algebraic approximations was also impenetrable to the most able research mathematicians. Back in 1941, the largest system of equations of algebra that could be solved involved only 29 unknowns. The ENIAC and UNIVAC supercomputers came along in 1946 and 51 respectively. The CDC 3300 supercomputer that I programmed in Corvallis, Oregon was introduced in December 1965, and in that year it was the fastest computer in the world, or the #1 ranked supercomputer. The CDC 3300 supercomputer was used to forecast the weather. The theorized parallel supercomputing that I invented in my head back in the 1970s was different from the practical parallel supercomputing that I invented later in the 1980s. Through 2 decades of trial and error, I learned that I could only invent the parallel supercomputer that could be invented, or rather the fastest supercomputer that the laws of physics permit me to invent. Prior to the 4th of July 1989, the parallel supercomputer was a technology that I knew but cannot explain or confirm by an experiment. I was the first person to be referred to as a supercomputer scientist. Supercomputing is a broad field. I am a supercomputer scientist that placed his emphasis on the science. Some supercomputer scientists are mathematicians who prove which abstract supercomputer can or cannot solve a grand challenge problem. Some supercomputer scientists are engineers who build supercomputers. Some supercomputer scientists are inventors who measure the speed of never-before-seen supercomputers and tries to invent the fastest supercomputer that is powered by new technologies. I was trained as a research mathematician, research engineer, and research physicist. I conducted my supercomputing research at the frontiers and at the crossroad where mathematics, physics, and computing met. In the 1980s, the United States Department of Energy compiled a list of 20 impossible to solve problems that were very important. Those 20 problems were thereafter dubbed the 20 grand challenges of supercomputing. Those 20 grand challenge problems were to computing what the 7 millennium problems were to mathematics. The reason the grand challenge problems that pertain to physics were exceptionally difficult was that each problem can only be solved by a polymath who has command and mastery of physics, algebra, calculus, and computer science. My parallel processed solution of the Grand Challenge problem was highlighted in the June 20, 1990 issue of the Wall Street Journal and was described as cover stories of top mathematical publications. My complete solution was described in my very lengthy series of online lectures. Only a polymath will have the confidence to tackle the Grand Challenge problem. Back in the 1970s and 80s, extreme-scale computational mathematicians didn't deem the parallel processing of initial boundary value problems of mathematical physics as merely difficult. Mathematicians deemed the parallel processing of real-world Grand Challenge problems as impossible. For that reason, it was then said that parallel processing was a beautiful theory that lacked an experimental confirmation. My contribution to the development of the computer, of the supercomputer, is this. I provided that lockdown experimental confirmation of parallel supercomputing, and I made that discovery at 8:15 in the morning of the 4th of July 1989 in Los Alamos, New Mexico, United States. I remember that date because it was the US Independence Day. I discovered practical supercomputing, and I discovered the supercomputer technology across my ensemble of 65,536 processors. That was the precursor to the current world record of 10.65 million processors. Thank you. Thank you very much. Thank you. I'm finished, Emeagwali.
Insightful and brilliant lecture.